Hi there, Algebra 1, 6.6, Systems of Linear Inequalities. Alright, objective, to solve system of linear inequalities by graphing. To model real-world situations using systems of linear equations. Vocab, the solution to a system of inequalities is the intersection of the solutions of each inequality. Every point in the intersective region satisfies the system. We are going to graph each inequality and shade the region showing the solution. The region where the two shadings overlap represent the solution to the system. Alright, you want to buy at least 3 ringtones, but you cannot spend more than $15. How many premium ringtones, which cost $1.50 a piece, premium, okay, and then top 10, which are $3 a piece. So, how many different ways can we make 18 or $15? All right, so there's a couple different things you can do. Okay, but what you need to know for sure is $1.50 per premium plus $3 for a top 10, so I'm going to go T, is going to equal $15. Okay? You can spend no more than 15, so it's going to be 15 or less. Alright, so there's my equation. Okay? Now, you could graph that and figure this out. Because if I graph that, $15 at net, or this, let's go premiums over here. And let's go top 10. Yeah. So with 1 top 10, we're at $3. 2, we're going to be at $3. Or at $6. 1, 2, 3. 4 is going to be $12. 5 is going to be $15. So right here, that's going to be the most we can of this. Now, we can also get where we want 1.5, which then that would go in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so what I'm thinking right now is this would be our first inequality. This would be making the fact that your P plus T is going to be greater than or equal to 6, because you at least want 6 new sums. So, this is this inequality. So you're going to have to shade everything out here. Okay? So that's that part. Now, this would be left. Because this is what you can buy. So this is how many you can buy of each, and you can shade in between. So I was wrong. You shade here. Alright. Because you need less than that. This is what it would add up, and you'd get $15. So, gotta be less than that. But you have to have more than 6 CDs. Well, you could have 0, so it could be right here. And it could be right here at 6. Okay, but it must be greater than, so we're going to shade above. So the area in which we can buy for solutions is going to be right here. Right in that area right there. It's going to be in between the red and the blue where they're both shaded. Okay? So that is your answer for that. You could choose any selection in here and get the right answer. Because there's more than one way to do this. But you have to at least do it that way. Alright. What is the graph of the systems? Yeah. There we go. Okay? Now, you need this in the slope-intercept form, so I'm going to minus. See, we minus 2x, so we're going to get y is less than negative 2x plus 1. That's that. Okay? Now, we have to find the other equation. And then we're going to graph them both. Alright, so we're going to divide by 4, divide by 4, divide by 4, divide by 4. We should get y is less than or equal to 3/4 x plus 3. Alright, so positive 3. 1, 2, 3. Got a dot there. Alright, we're going up 3. 1, 2, 3 over 4. Up 3 over 4. Down 3 over 1, 2, 3, 4. Down 3 over 4. So we have something that looks like this. All right. Okay, it is a solid line because it is greater than or equal to. It is greater than, so we're going to shade everything up here with the brown. So everything up here is shaded. All right. Now our other one, we have 1. Is our y-intercept. So we're going to be right here. We're going to put a dot there. We're going to be up 2 over 1. Up 2 over 1. Up 2 over 1. 2 over 1. So we have that. Now, this one is a dashed line. Okay. Okay, it is less than, so we're going to shade below. So the answers to these inequalities is right here. Right in that area right there. Okay? Okay, same thing here. Hopefully my markers hold up. Okay? So we'll try to use this one to go this way because black should hold up. Alright, so we got that. Okay? This first one. We're going to have y is less than 4x plus 7. So we're at 7. 1, 2, 3, 4, 5, 6, 7. Okay, we'd be down 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. So we have a line that looks like this. Okay? It would be dashed plus 6, so we're going to be right here. Okay, and we're going to be up 2 over 1. Oh, I forgot to shade the black. Black would be less than, so it's everything over here. Okay? Including this area up in here. Okay, and then let's go this way. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So we have a line that looks like this. Okay? And that's going to be greater than. So it's going to be the space up in here that is going to be your solutions. And obviously, as those lines extend out, that area is going to get bigger and bigger and bigger. But right now, with what I graphed, I only have that small little area up there. Alright, writing a system of inequalities from a graph. Okay? So, I'm going to attempt the red probably first. Alright, we have this line going through here. I'd say it goes through at 1 right here. Slope looks to be a 1 to 1 in a positive direction. So I have y. Alright, it's got to be greater than or less than because it's dotted, right? So I'm going to go, it's below, so I'm going to go less than. I just said the slope was 1x, alright, and we cross at -1. There's my equation for the red line. Now, the blue one. Once again, dotted line, we're shading below again, so we're going to be less than. Alright, we cross the y-intercept at 6. Okay, and let's see, what else can we say about this? Let's check our slope here. Looking for a point I went through, probably about right here. Up 1, 2 over 1. And it's a negative because we're walking downhill. So it's a -2 over 1 x plus 6. There's my 2 equations. You can buy a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long. You have 126 feet of fence. What is a graph that shows you the possible dimensions of the dog fence? Okay, so you know that your deal, your length of your deal has to be 10. So you want to build a fence for a regular dog run. You want the run to be at least 10 feet wide. So at the smallest that your fence can be for a width is going to be 10 feet. Okay? Okay, I'm just thinking of graphing this right off the bat. Alright, so that would have to be, let's go 2, 4, 6, 8, 10. So we're right here. Alright, so my width is 10, and it could be larger than this. Alright, let's go 12, 14. Alright, the run can be at most 50 feet. So we're going to say this is 50. And this is going to be my length. Okay? So it can be no larger than that. So, all my widths, if I went up to this point right here, can be larger, okay? Everything here, I can have whatever width I want, but it's got to be, or gotta have any length I want, but it's gotta be less than 50, so we're down over here, okay? So, now I've created that, but the thing is, length plus width, which to get the perimeter, because we were looking at perimeter 2 and 2. Alright, 2L plus 2W will give me my perimeter. Well, we were told that at most you can have is 126 feet of fence. Okay? So realistically what I could do is divide this by 2, divide by 2, divide by 2. I'm going to get, let's see, 63 right here. Alright, L plus W is less than or equal to minus my L over. I'm going to get W is less than or equal to negative L plus 63. So, realistically, I'm going to try to do a different color. This is going to be this equation right here. From 63 up here down to, well, you'd be down 1 over 1. So you'd be a 1-to-1 ratio, which means you probably could go out to here at 63. So you'd be in this area right here is the amount of fence you could have that makes both of those, or all three inequalities correct. Alright. What is the graph of the system? Okay. This is my points down the middle here. Okay, so we have that. Okay, x is less or greater than 4. Well, or y is greater. Well, y is 4 is 1, 2, 3, 4. It's right here. Draw across, go like this. Alright, it's greater than, it's a dashed line because it's not equal, which is really nice part about using a marker board. Alright, I'm up here. Okay? Sometimes you'll have a situation in which now we have y is less than 2. And that's going to be a dashed line. And that would be everything down here. So, there is nothing that will solve both of these inequalities because they never overlap. They never, ever will. There is your homework.